So you are studying the applications of conductance. Applications of conductance. So we have discussed that first application is on dissociation constant. On dissociation constant. We already discussed that a lot of it. Previous class we have discussed on dissociation constant. And second applications on solubility and solubility product. This one also we have already discussed. And third applications which we are going to study today, that is conductometric titration. This conductometric titration, this is one applications of conductance. So this one we already completed, this one we already completed. Today we are going to discuss the third applications of conductometric titration, conductance. Let's say conductometric titrations. Conductometric titrations. So first of time, what is the principles behind these titrations? The principles is, let's say, the principles behind these titrations is during the titrations, one of the ions replaced by another, and these two ions differ in their, ionic conductivity. And result of this or you can say result of that, the different conductance or conductivity in the solutions. So while doing the titrations, what we are doing, that we take, let's say, in beaker, what we do, we take any solutions. Let's say here we taking any acids, and we are adding the base, straight from any titrants. So drop by drop we are adding base. So any base I am adding. So one acid is replaced, acid react with base, and with that new will form. You know that acid plus base form salt plus water. It means one of the ions, means acid and base, in between the ions will be replaced and form salt and water. So due to this replacement, the ionic conductivity will changes, and due to this change there will be change in the conductivity in the solutions. That is called conductometric titration. So this is the behind of the titrations. This titration means the conductivity value of the solutions will change. by adding one of the ions with another. So let's say the cases we will discuss. Case 1 is let's say strong acid plus strong base. Example, let's say I am taking HCl plus NaOH. So the graph will be conductance, and here will be volume of NaOH. Volume of NaOH. So but here is bigger. Here I have the acids, and I am adding the let's say the colors don't look a color. I'm just for differentiating, I'm giving different colors. Maybe the color of this may be different. So I'm adding the base drop by drop to the acids. So this is, let's say, base. I'm adding base drop by drop, and this is acid. I have the acid. Okay, so due to that, what will be the graph? Graph is K versus volume of NaOH. So what is the change in the conductance? Okay, so since acid HCl, so HCl is strong acid, so this is completely dissociated, that is H plus Cl minus. Okay, so this is a strong electrolyte or strong acid. So when T equal to 0, not let's not dissociate, then this is 1 molar 0 0. So when T equal to T equilibrium, this is completely dissociated. So the acid completely dissociated, and we are adding drop by drop to the solution. Means in the solution this is present. In solutions this is present, means H plus and Cl minus is present. And similarly NaOH also strong acid. So I will do here NaOH. This is also strong electrolyte, so this will dissociate into N plus OH minus. T equal to 0. Let's say this is also 1 molar 0 0. T equal to T equilibrium 0 1 molar 1 molar. So in solutions, whenever you are adding, then solutions what is present, Na plus and OH minus, this H plus and HCl. So whenever these two will react, then what will form? Whenever HCl and NaOH, HCl means in the solution H plus and Cl minus is present, will react with NaOH, means in solution Na plus and OH minus present. So when this react, then this Na and Cl will form compound salt, and OH and H will form water. So this what the while forming salt, what are the electrolytes? So this is again a strong electrolytes. Yes, this NaCl again a strong electrolytes. So this is completely dissociated into Na plus Cl minus. Let's say T equal to 0 1 molar 0 0. T equal to T equilibrium 0 1 molar 1 molar. So this is completely in solutions. This is present, means NaCl is not present, only ions is present. So Na plus Cl minus is present. So whenever you are reacting, whenever an HCl and NaOH will react, then previously H was present, and whenever you are adding NaOH, so Na plus OH minus is present, they will react and form the NaCl. And we know for HCl, the ionic mobility of H plus is greater than Na plus and greater than, that is greater than H plus and greater than OH minus greater than Na plus. So ionic mobility of H plus is highest. Okay, so that we will discuss that we already discussed in previous class. Due to Gauss conductance, the H plus ionic mobility is highest due to Gauss conductance. We already discussed in the previous class. So since this ionic mobility is very high, means in HCl H plus is there, and since ionic mobility is high, so if ionic mobility is high, then the conductance is due to movement of ions, so high conductance. So high conductance means HCl will have this amount because high conductance, and we are adding the NaOH, means whenever we are adding Na and OH means that react and forming NaCl, means it is forming from these two we are converting to this one, so this will be decreasing. Okay, because H plus concentration, the ionic mobility of H plus is replacing by Na plus, and Na plus is lower than H plus, so it will decreases. So it will come to this point up to whenever the whole acid is neutralized with base. So when acid and base neutralized, means when to full acid has completed, then only in the solutions now NaCl is present. So in these times, so fully HCl and NaOH completely neutralized, I mean HCl is completed. So here it will stop. So when this is the equivalence points where HCl is over, HCl is complete, and after that again we are adding NaOH, means this here NaOH is increased, so again we are adding NaOH, then what happens, that again we are adding, so in the solutions now what is there, NaCl is there, in solutions NaCl is there, that means Na plus and Cl minus is there, and we are adding again NaOH. It means this salt and NaOH will not react, but the concentration of OH minus will increases, because this is also strong electrolyte and this is complete dissociate, means in the solutions base is increasing, it means OH minus concentration is increasing, and OH minus concentration is more than Na concentration. So now in the solutions OH minus concentration is increasing. Here completely whenever it is neutralized, on the time Na was there, that's why H2 NaH decreases. Now you are adding again and again base, it means you are adding OH minus, so the solutions OH minus concentration is increasing. So OH minus concentration is greater than ionic mobility of Na, means ionic mobility is high, then high conductance, so this again increases, but it will not increases up to this, because H ionic mobility is higher than OH concentration, so it will stop up to here. So let's say this value is like this, then this value is like this. So conductance of H plus is high, after that conductance of OH minus, this is, let's say conductance of H plus, and this is conductance of OH minus, this is conductance of Na plus. So this will be the graph of conductance versus volume of NaOH, or strong acid versus strong base. So this is the graph. Okay, now we will discuss for the next case, that is case 2. So now we will discuss, let's say if we have the weak acid plus strong base, let's say weak acid is I will take acetic acid, CH3CH, any weak acid we can take, and strong base is, let's say again we will take NaOH. So before doing the graph, let's understand the what is there in the solutions. So in the solutions, let's say here I have weak acids, and we are adding drop by drop the strong base. So here we are adding NaOH drop by drop, and here we have its weak acid CH3COH. This is weak acid. So you know that weak acids, this is partially dissociate, CH3 CO minus plus H plus, and when T equal to 0, let's say 1 molar is there, then no dissociation happen, and whenever T equal to T equilibrium, from here only 1 minus 0.0 molar is dissociate. So this is from 0.01, this is from 0.01, means very less amount of, at equilibrium this is present, means this is present in the solutions, means very less amount of 0.01 is present, H plus concentration, very less amount of CH3CO minus is present, and high amount of CH3CO is present. This is nearly equal to 0.99. Okay, this amount is present CH3COH, and very less amount of dissociate, means its ions are present 0.01, 0.01, like that. Okay, so this is present. So whenever this in these solutions this is present, and we are adding the strong base, that is NaOH, and this is completely dissociate because this is strong electrolytes. Let's say so completely dissociate into ions. This is not left, only this is present. So whenever you are adding dropwise drop to NaOH to the solutions or to the acidic acids, then what happened, that this much will react with this one. So what happened, whenever we add drop by drops, let's say small drop I added NaOH, then this will go, and this is present, this and this, so this will react with the small amount of this one, and what it forms, the small amount of CH3, small amount of CH3 CO minus, let's say small amount 0. React with this NaOH I am adding. So let's say first I will do, whenever you are reacting CH3 COOH plus NaOH, it means here very less amount of this is there, means CH3 CO minus, and H plus is there, but very less amount, and this is very high amount is there. This is Na plus and OH minus, so very high amount. So what happened, this will react with this one, so CH3 COO Na plus water, but this is very less amount of this one was there, 0.01. Okay, so this amount is reactant for this amount of 0.01, and here also from 0.01 means very less, you have but small drop after the this H form, and whenever this H form, this is a strong electrolyte, so this what will do, this will completely dissociate into CH3 CO minus plus Na plus, T equal to 0, let's say its value is 0.01, 0, T equal to T equilibrium, this is completely dissociated into this. So now what happened there, so one drop whenever you add, this has happened that whenever we add one drops, then this will react with NaOH, and this H form and this H form. Okay, this amount of this H form. Now the question is this H form and this again become a completely strong electrolyte, so this completely dissociate and form this, and this is present in the solutions. So if you notice that acid is there and acid is there, and at the same time this is also there. Then what happened that here we see this and this have the common ions. So you know that in the solutions, you know, if this concentration is there and this concentration is there, this concentration is increases in the solutions. If this concentration increase in the solutions, and in the weak acid, you know that by Lee-Chatter's principle, if the concentration of product increases, then reaction will shift backward directions. So if it shift backward directions, means CH3COH dissociation constant of CH3COH again decreases. Although past only it is very less concentrations, very less amount of dissociate, but again due to common ion effects, this again decreases in a huge amount. So due to common ion effect, it again decreases, means dissociation constant now it become very less, like 0.001 like that, 0.001. So this again decreases in a huge amount. That's why whenever we do the plots, this is volume of NaOH and this is conductance. Then you are adding, whenever you are adding NaOH to CH3COH, due to whenever I add one drop of NaOH, then these things has happened, and here this has forms, and this what due to common ion effects it may become a problems for acids to not to dissociate due to common ion effect. So first this CH3COH here, since this is weak acid and very less amount of H plus it dissociate, so its conductance is very less, because this is weak acid and very less amount of H plus it is dissociating. So its conductance is very, H plus is very less amount, we say the concentration. So its K value will be very less, like say here it is there, because of very less amount H plus. H plus mobility is higher than OH minus, than Na plus. It's fine, but this concentration has to be also good amount, then only this value will be high, but this concentration is very less amount, like negligible, so its conductance is very less. Okay, after that, due to common ion effect, this one also, whatever the coming, that is also decreasing. Whenever I add one drop of NaOH, previously this amount of H plus was coming, but whenever I add one drop of NaOH, then what happened? It forms these types of reactions and CH3COH prepare, and this makes a problem of CH3COH because the common ion effects, and it do the reactions in a backward reactions, so that CH3COH not able to dissociate. So this dissociation constant decreases to a very less amount. So from here this was there, this again decreases, so it will again decreases like that. Okay, so here let's say 0.01, that one was there, here again decreases 0.001. okay, after that whenever I am again adding again NaOH, I am adding, then what happened? I am continuously adding in these directions, NaOH, volume of NaOH increasing. So again if I am adding NaOH continuously, then what happened? NaOH is coming to the solutions. So whenever this NaOH coming to the solutions, again this is synthesis CH3CONA, and CH3CONA is this one, but now it's CH3CONA. This is a salt. This is a salt. Okay, so whenever NaOH will come, although CH3COH not able to dissociate because of common ion effects, again this is happening, so this is not able to dissociate, and what is forming, that CH3CONA will forms, and this is making a problem for dissociation of that. But this NaOH will not react with CH3CONA because this is a salt, this is a acid, and this is a base. So although this is not able to dissociate due to this common ion effect, but this is also fact that base will not react with salt, because this is a salt and it will not react with it. so it has to react with this. So CH3COH has to dissociate again. This has to dissociate very little amount, but it has to dissociate, and whenever it dissociate, on that time CH3COH again forming more and more. Yes, CH3CO again forming more and more. If this is forming, then what happened? So what I said, whenever CH3COH react with NaOH, CH3CONA is formed, and this CH3CONA will have the common ion effects with CH3COH and do the reactions in backward directions. It's fine, but again we are adding NaOH because we are increasing the volume of NaOH. So if you are adding more and more NaOH, then this NaOH in the solutions, what is there? CH3CONA is there and CH3COH there, and you are adding the NaOH. Then NaOH will react with this one or this one. Obviously this base is react with acid only, not with CH3CONA. So it again react with this one, although very less, but it will react. Again this is forming. So continuously this is increasing. This value increases in the solutions, and in solutions what is there? CH3 COH is there and CH3 CONA is there, and we adding in solution, this is there, and we adding NaOH. So if you add NaOH, NaOH will not react with this but react with this one only. So because this is salt and this is acid and this is base, so this will react with this only, it will not react with this. So if it will react with this, then again small amount, due to common ion effect, very low small amount of CH3COH will dissociate, but it will react with this, and whenever it will react with, again this is forming. This is one drop now, what has formed, again it will form. Means continuously you are adding NaOH, means continuously it will react with CH3COH, and continuously CH3CONA is releasing in the solution. So in solutions, concentration of CH3CONH increases and concentration of CH3COH decreases by adding NaOH. So if concentration of CH3CONA increases, this is the strong electrolytes, yes, and this CH3COH is weak electrolytes, and CH3COH, although it is releasing H+, but very less amounts, but this is the strong electrolyte and it's releasing the Na+ in a very huge amount. So although ionic mobility of H+ concentration is more than Na+, but if the concentration of Na+ is very high than H+ concentration, then conductance will dominate. So conductance Na+ will be high than H+, because its concentration is, let's say, 1 molar. It will become, because after adding more and more, its concentration, this concentration is decreasing continuously. Okay, because whenever you are adding, then this dissociation constant which decreases due to common ion effect. So this is value which decreases, H+ concentration decreases more and more whenever you are adding more and more NaOH. So if this concentration increases, Na concentration increases, so conductance is high, so this graph will shift to like this. Okay, this is happened because due to decrease in concentration of H+, because due to common ion effect, acid dissociation of acid is decreases. That is happened due to decrease in the concentration H+ due to common ion effect. And this graph of increasing graph is due to increase of CH3CONA or Na concentrations. Okay, now what happened that after these points this acid is completely, here it says that acid is decreasing from time to time, so time will come, you are adding more and more NaOH, then this become 1.5 molar and this is become complete H plus concentration, that is CH3COH is completed 0, means H plus concentration decreases means CH3COH is completely finished. So on that time this is the equivalence point. Okay, after that what happened, we are adding more and more NaOH, so now we are adding more and more NaOH, means NaOH, this completely dissociated to Na plus plus OH minus, and in the solutions what is there, Na and OH minus is coming, and in the solutions now after finish of acid CH3COOH, what is there in the solution? In the solution CH3CO minus is there, Na plus is there, and water is there, and you are adding more and more NaOH, then what happened, in the solutions OH minus is coming, because this is not react with CH3CONA, because this is base and this is salt, so no reactions happen. Only after adding more and more NaOH, only OH minus concentration is increases in the solution, and this is also a huge amount because this is strong electrolyte, and we know the ionic mobility of OH minus is greater than Na plus. Don't confuse with that, H plus concentration is more than OH minus concentration, more than Na plus concentration, but here that what I do, that conductance of Na plus is greater than H plus I did. Why? Because this concentration is very less amount, that's why I did the conductance of this is higher. If the same concentration and this is, let's say 1 molar, that's why this conductance is high, but if the conductance of Na plus and I did H plus, and if have the same concentration like 1 molar, then this conductance is very high, but here since the conductance is very less, that's why I did this is more conductance than that one. Okay, so here since OH minus concentration is also coming in a huge amount, because this is a strong electrolyte, so this will dominate in conductance. Okay, previously Na was there, due to Na the conductance was there, now OH minus is coming, and that is also from strong electrolyte, so OH concentration is more than OH concentration, this concentration is same, but the ionic mobility of this is high, so conductance is high, so after that again this value will increase like that. This is due to increase in the adding more of OH minus, due to OH minus this is increase. So let me do the graphs here, bigger more. Let's say this graph is, this is K and this is volume of NaOH here. Okay, so due to acid, that is weak acid, so this it decreases here, this decreases is due to common ion effect, or we can say due to less dissociation of acid. Okay, or less dissociation of acid, this is the reason. After that here after that whenever you are adding more and more NaOH, then what happened, again that previously and less dissociation of acid, and CH3COH also very less, and here that less of CH3CONA also, so it is dominated by dissociation acid, only H plus is there. Whenever you are adding more and more acids, then what happens, that CH3COH will dominate, and if it is dominate, then this is more Na concentration is increasing. Here the concentration of Na is less. Here concentration of Na plus is less, and also concentration of H plus is also less, and from here to here it decreases due to common ion effect. Okay, but now what I says, this graph will be increased like that. This is due to increasing the concentration of, this is due to whenever adding more and more NaOH, more and more CH3CuNa will form. This is due to increase the concentration of Na, because more and more CH3CuNa will form, and obviously decrease in concentration of H plus, because this is all due to common ion effect. This is decreasing more and more, but Na is forming more and more, and due to Na this is come. Okay, and this is go even more than that, because this is due to weak acids and this is now strong electrolytes. Okay, so this value is more than that now, and here that acid is fully completed, because we are adding more and more NaOH. After that CH3COH, that is due to common ion, that is very less dissociate, but if you are adding more and more NaOH, that time will come when CH3COH completely over. So here, so we said less in concentration HF, on that time concentration of H plus is finished. So when it is finished, then if you add more and more NaOH will not react with CH3CONH, so only OH minus concentration is increasing in the solutions. So this graph will become like this. Okay, so this is due to increasing of NaOH, or this is due to increase of OH minus concentration. Okay, so this graph is, if I draw, then curve, and then volume of NaOH. Actually graph, it will let very less amount dissociate. After that this will increase, after that, and then it will increase like that. Actual graph will look like very less amount of that, because one drop, after one drop only this factor is happening. So one drop only, that decrease this is due to only one drop of NaOH. When one drop of NaOH we put, little amount of CH3CON will prepare, and that affect the dissociation of acid. So this is decreases, because whatever H plus is coming previously, that also becoming less and less, so this is decreases. Okay, after that whenever adding more and more drops, then whatever CH3CONH concentration is increases, not H plus concentration increases, CH3COH, and this graph is increase in concentration of Na plus, or you can say increase in concentration, increase in CH3CONA, and decrease in concentration of H plus, because H plus H continuously decreases, and this graph is, this has come due to decrease in concentration of H plus. So here also concentration H plus is decreases, but increase in the concentration of Na, CH3CONA. This is a strong electrolyte. So this graph has come, and this graph is due to increase of concentration of OH minus, because after that also you are adding OH minus. So OH minus will not react with CH3CONH, because this is a salt and this is a base. So OH minus is coming to the solution, so OH concentration increases. So since OH concentration, OH ionic mobility is high, so it will increase like that. Okay, so this is the graph. Okay, so you understand that common ion effect, how it affects. So normally if you say, simply if you say one word, this is due to common ion effect, and this is due to increase in the concentration of CH3CONA, and this is due to increase in the concentration of NaOH. Okay, So this is the case 2. Now we'll discuss about of the case 3. Case 3. Case 3 is, let's say, what I do here. What is the case 2? Case 2 was weak acid versus strong base. So this will be strong acid plus weak base. That means in the solutions weaker I have what? Let's say I am adding drop by drop. This I am adding weak base. Let's say here I am taking weak base. We can take any weak base. Let's say we take NH4OH and strong acid. So this is strong acid is here. So strong acid is let's say HCl. Okay. So this one actually we can write it weak base plus no. So strong acid plus weak base. Okay. So what is that? This weak base. So first we understand the what is weak base. What happened? This weak base is partially dissociate. So this will become NH power plus OH minus. When T equal to 0, let's say this is having 1 molar, 0, and whenever T equal to T equilibrium, very less amount of dissociate because this is weak base. So let's say 0.01 is dissociate. This is 1 minus 0.01. So this is also 0.01. Okay. So this is present in the solutions. So this is nearly equal to how much? Let's say T equal to T equilibrium. It is 0.99. And let's say this is 0.01. Yes, 0.01. So this is present in the solutions. Sorry, this is present whenever we add 1 drop of NH4OH. It means we are adding very less amount of NH4 plus, very less amount of OH minus. Because actually it comes like this. Because whatever the equilibrium, this is the actual what it comes. Okay, we are adding in the name of that you are adding, but actually it's coming this much because this is weak acid. Like we can say that example, somebody giving you 20 rupees, but it is reaching to you only 5 rupees or 1 rupees, like that. We are adding 1 ml of concentration of NH4OH, but it actually coming 0.01, this amount. Okay. Now, and I have another is strong acid. Another I have is strong acid. Strong acid, let's say HCl. So this is completely dissociate, H plus Cl minus. So T equal to 0. Let's say this 1 molar, 0, and T equal to T equilibrium. Let's say this is completely dissociate. So 0, 1 molar, and 1 molar. So here, if somebody is giving you 20 rupees, then that is also reaching to you 20 rupees because this is completely dissociate. Okay. So in the solution HCl is there. HCl means this is the equilibrium, means what is the actual is present. So this 1 mol of H plus 1 mol HCl is there. This is not there. Okay. So this is there in the solutions. And whenever we are adding one drop, then we are adding this amount of 0.01 molar, 0.01 molar of this NH4 and OH minus we are adding. Okay. So whenever I add, let's say 1 drop of NH4OH, I add. Then what happens? Whenever I add 1 drop of NaOH, then this NH4OH will react with HCl. Here NH4OH means very less amount of this, and this is present. Okay, so this is present. Let's say 0.01. Why? Because this OH minus. Okay, and this is present. Let's say 1 molar. So this will react, and what will form? NH4Cl plus water will form. So here this 0.01. So here at t equal to t equilibrium, this is 0.01, so this is also 0.01, so this is also from 0.01. Okay, this is in the solutions whenever I one drop of NaOH, whenever I add this H4. So this NH4OH, NH4Cl, this is a strong electrolyte. This NH4Cl is a strong electrolyte, so this is dissociated into NH4 plus Cl minus. So this is, let's say t equal to 0, let's say this is how much, 0.01, 0, so and t equal to t equilibrium, this is completely dissociated, so 0.01, 0.01. So this is there in the solutions. So whenever I add one drop of that, then this react with this, and this dissociate in this amount of NH4OH, and this amount of Cl minus is present in the solutions. Again, whenever I am adding another drop of NH4OH, then what happened to this NH4OH? This NH4OH will become a this NH4OH, whenever I add, then NH4 itself is a weak base, so this dissociation is very less, and again in the solutions this is present. So due to this and this is same, so the common ion effect again play here, so this concentration increases, so this again dissociation constant of NH4OH decreases. So this dissociation constant of this is decreases, so very less amount of valuable comes. So for another drops, this come very less amount of like 0.01, 0.0, sorry 0.09, 0.009, this amount. So again it decreases. So what happened that what we are doing that here, it's better to write there only, so that it is easy to here I am doing the graph. So HCl is there, this is volume of NH4OH, because we are adding NH4OH, so this is in here, HCl is there. So HCl means this is strong electrolyte, completely dissociate, so complete amount of H plus is there, and H plus concentration is also high, and its ionic mobility is more than let's say here what are there, NH4OH is there, so it is more than OH minus and more than NH4 plus. So this ionic mobility of this is high, so conductance of this is also high. This is conductance. So it is this is because this is strong electrolyte, and strong electrolyte means completely dissociate, so high amount of H plus is there, means high conductance. So let's say this amount of HCl is there, and whenever you are adding that NH4OH from top, drop by drop, so due to this common ion effect, what happened that this adding of NH4OH, that base coming to this solution, that is NH4 coming to this solution, or OH minus coming to this solution, that is decreases. So whatever we have to add more amount of NH4OH. If you add more amount of NH4OH, so let's say this we have to add more amount of NH4OH, then only this concentration of HCl will decreases, because whenever we are adding one drop, then actually we are adding 0.01 drop, and in the next drops, whenever adding another NH4OH, due to common ion effect, this again decreases this, and this is going to 0.09. Another drop, let's say 0.009. So very less amount. So we have to add more number of NH4OH, means more NH4OH we have to add. So here adding up NH4OH, or let's say more number of, or let's say more volume of NH per OH is needed, because due to common ion effect, whatever you are adding, let's say 1 drop means actually you are adding 1 mole, but it's coming to the solution only 0.01. And in the another drop again you add 1 molar, then what happened, this due to common ion effect, this again decreases to this. So we have to add more volume of NH per OH, then only you can decrease this HCl concentration. Let's say up to this. Okay, after that like that we add more and more, then at the time will come when HCl is above. So here that HCl is above, HCl is finished. So now in the solutions what is there, if HCl is finished, then what is preparing after reacting with HCl, NH per Cl is there and water is there. So in the solution after finish of HCl, after finish of HCl, what is there in the solution, NH per Cl is there, it means NH power plus Cl minus and water is there, and we are adding more and more NH per OH weak base we are adding. So if this will add, this is base and this is salt, so this base and salt not react, but it but OH minus concentration is coming to the solutions. Okay, but this is very less amount due to common ion effect. This NH per Cl is increases more and more, so this value will decreases more and more, right? Since so this is increases in a huge amount, completely dissociate means complete more number of NH per Cl is there. This graph, right? So more number of NH per Cl is there, and this is completely dissociate and give NH power plus Cl minus, and you are adding more and more NH per OH. NH per OH means that is partially dissociated to NH power plus and OH minus. So we have seen that due to common ion effects, okay, I will discuss here only 2 equal to 0. Let's say 1 molar. Let's say. So now let's say T equal to 0. Let's say 1 molar was there, 0 0 T equal to equilibrium. Let's say. Then whenever you are adding more and more NH per OH, means more amount of NH per Cl is prepared. Yes, because whenever NH per OH will come, it will not react with NHCl. That's fine, but another see. Now at that, whenever this is reached to here, then completely HCl is finished. If completely HCl is finished, means more number of NH per Cl is there, because this is reacting NH per OH, NH per plus OH minus it's come, and this is H plus H, and that is react with NH per OH and NHCl, and NH per Cl was synthesizing. So if more amount of NH per OH adding, then more amount of HCl, means here we discussed, right? So more amount volume of NH per OH is needed to decrease the concentration of H plus, so it is decreases. So on that time when HCl is finished, then likewise fully HCl is over. So here more amount of NH per Cl is synthesized. Since more amount of NH per Cl is synthesized, then this is completely, this value is very high, and if this value is very high, then this affect this, because here common ion effect is there. So whenever you are adding this one, so let's say this is again decreasing, because drop by drop this is decreases due to common ion effects, decreases, and this value is already very high. So whenever you add, it sees that in the solution this concentration is very high, so it will shift the reaction in polar directions. So if concentration is very high, then it says that this concentration is very high, that then we can't do the dissociation. So this is completely prohibited. So If you add more and more NH/OH also, the solutions become constant. Why? Because this is very high. Then this concentration in the solutions, this is high because solution this is present, this is also present. So if you add more and more, this is more and more synthesized. Since this concentration is more high, then Lee-Chatter's principles, we know that if this concentration is high, it will shift the backward reactions. But if you are adding more and more NH/OH, means more and more NH/Cl is synthesizing, means NH4 is coming, means more and more this is coming. So this is again against the Lee-Chatter's principle. Lee-Chatter's principle says that if this concentration is high, then it will shift the backward reactions. So if this is very high, then it is become very in backward reactions. It means this dissociation is completely forbidden, means this is not dissociate anymore. So if this dissociate not anymore, then this become only, this is due to only NH/Cl only, not because of NH/OH, because NH/OH not dissociate anything. Like if a person is giving you 20 rupees, if a person is giving you like 20 rupees and that is reaching to a person's previously 5 rupees, but at the same times another person's giving him, and let's say this is the examples like this, let's say you giving to a person's 5 rupees and he need only let's say he need 20 rupees. Okay, then what happened that if we give him 20 rupees and that is reaching to him 5 rupees, and another person he need 20 rupees and another he needed 20 rupees, and another person is giving him 15 rupees, and after some times like time to time you are giving to him, it decreases to 4, 3, and that person's increases to like 16, 17, and time will come you give 1 rupees and other person giving 19 rupees, and if you are giving more and that person is giving him more and more, time will come he give 20 rupees and he has giving 0 rupees. Although you are giving 20 rupees, that is reaching to him 0 rupees because other person is giving him 20 rupees and he need only 20 rupees. So like the same conditions, like if you giving more and more NH/OH, more and more NH/OH, but that reaching to him is this much because other persons is giving him that his requirement 20 rupees. Like this is given by NH/Cl, means this here NH4 is giving to this person 20 rupees is fulfilling, and whenever you are giving NH/OH, that is affected and that value is coming nearly 0.1. That's why whenever this comes, this is only giving by NH/Cl. Yes, this is giving only by NH/Cl, and this NH/Cl concentration is this much. So if you give more and more, then also this will become constant, because whatever you are giving NH/OH, that is going to him is 0. Okay. This is the third case. Let's discuss the fourth case. Fourth case is whenever we add weak acid plus weak base. Okay. So this is the examples, like if we have here, let's say this is weak acid and you are adding drop by drop weak base you are adding. So this is weak acid and you are giving drop by drop weak base. So well, let's say weak base is NH4OH and weak acid, let's say CH3COH. Okay, so let's see the first what is happen in the solution. So whenever you are giving that, whenever CH3COH is present, then it means this is not complete dissociate, so this is dissociate partially minus plus H plus, so T equal to 0, let's say 1 molar, 0 0, let's say T equal to T equilibrium, so this is become 0.99, so 0.0 very less amount dissociate. So this is present in the solutions. Similarly, we are adding drop by drop NH4OH. This is also weak base, so this is partially dissociate, that is NH4 plus OH minus, and let's say T equal to 0, 1 molar, 0 0, T equal to T equilibrium, let's say 0 0.99, 0. No, sorry, 0. 0.01, 0.01. So this is present in solutions. Okay. So now we are adding in the solutions this amount of CH3COH there and this amount of H plus is there. Okay, and you are adding drop by drop NH4OH means we are adding this amount of NH4, this amount of OH minus. So if the graph it will draw, then so this is volume of NH4OH, this here, and this is conductance. So in the acid this is there means very less amount of acid, means let's say this amount very less amount of H plus, so this amount is there, and we are adding drop by drop this NH4 plus, and this itself is a weak base, so this is coming very less amount of, okay, so but very less amount, but it's coming something, right? So NH4 OH, then this is coming what, this is means NH4 plus is there, OH minus is there, and NH4 OH is there. If we giving this means this is there in the solution, this is coming into the solutions. And if we have CH3 COH means in the what is the solution, CH3 COH is there, CH3 CO minus is there, and H plus is there. So although it is coming very less amount of NH4 plus and OH minus, but coming something, right? So this will react, NH4 plus will react with CH3COH minus, so that is react CH3CO NH4 plus water. So since this is weak acid, this is weak base, but this is salt. So salt has more ionizations than weak acid and weak base. So this is more ionized. So whatever this is coming, so this is more ionized, let's say CH3. Although this is also weak salts, but due to because this is salt, so compared to weak acid and weak base, this ionize more amount. Let's say here coming 0. Let's say here 1 molar, then T equal to 0, so 0 0, T equal to T equilibrium. This is also weak electrolyte, but more dissociation than weak acid, weak base, because this is salt. So from here, let's say this is dissociate into 9, so 0.02, 0.02. So this dissociation, but this weak acid is 0.01, but this dissociation is 0.02. So compared to weak acid, weak base, this dissociate is more because this is salt. So this is present in the solutions. Okay, so whenever you are adding more and more NH4OH, means this is reacting with CH3COH, and more this amount is synthesizing, and this synthesizing what giving more and more this and this and this, because this is a salt, this dissociate little bit more than weak acid, weak base, means more amount of this, and this is coming to the solutions. So this is due to weak acid, and in time you are adding more and more NH4OH, means more and more NH4OH you are adding, means more and more salt you are synthesizing. Okay, so this is increases because whenever we are adding more and more NH4OH, means more and more salt is synthesized, and salt is more dissociation than weak acid, that's why it is increases. And at that times when this weak acid is over, here weak acid is completed, then if weak acid is completed, then if weak acid is completed, then what is there in the solutions? this CH3CO NH4 plus salt is there, plus what is there, with that we are adding NH4 OH. So whenever this is weak acid finished, then only this is there and you are adding more and more NH4OH. But this NH4OH is very weak acid, very less dissociate, and very less amount of NH4 plus will comes, because this is weak base. So after adding more and more also, this is become nearly constant, because this already CH3CO, this is increases only because of this salt, because salt will dissociate more than weak acid and weak base. But whenever this weak acid is finished, then no more salt will synthesize, because so salt will synthesize if acid plus base will react, but acid is over, so only base is coming, so and base is a weak base, so this is become this graph. Okay, so now the next thing, that is last examples, that is last case, that is if you have weak acid plus strong acid, plus we are adding that weak strong base. Okay, so in the solutions, what is there, we are adding, let's say, so we are adding strong base, let's say I am adding NaOH, and here weak acid and weak base is there. Weak acid, let's say CH3COOH is there, plus HCl is there. Then how will be the graph looks? So we already discussed what is the CH3COH. Yes, CH3COH is partially dissociate. So I am doing very fast because I already discussed these things. So T equal to 0, 1 molar, 0, 0, T equal to T equilibrium. So let's say this is present in the solutions, and this is present in the solutions, and we are adding the strong base, so that is, let's say NaOH. This is also strong electrolyte, so this is completely dissociate, and T equal to 0, let's say this is 1 molar, 0, 0, and T equal to T equilibrium, let's say 0, 1 molar, 1 molar. So this is in the solutions. This is present in the solutions. So whenever you are adding the strong base and in the solution both are present, so let's say I add the 1 drop of NaOH, so I add the 1 drop of NaOH, then what, this will come to the solutions, and in the solutions, this is present, in solution this is present, means this is present, and this is present. So this will react with what, let's say it will in solution this is present, and we are adding NaOH. Okay, means Na plus and OH minus is coming to the solution, you are adding drop by drop. Okay, so this Na plus and OH minus, this will react both with this and this, although this is very less and this is very high amount is there, so this base will react, OH minus will react with this also, this also this also react, but this is very less. So let's see what happened whenever this NaOH will come, so this also react with CH3COH, and this will form CH3CONa plus water will form. Also this will react with HCl for NaCl plus water. Okay, this will, because this is also present little amount, although little amount but present, right? This is present huge amount, so this maximum react with this, also react with this one also. But whenever this will react, then this is present 0.01, because H plus I am taking CH3CO minus. This actually means this is the actual, so that's why I am putting this value. This 1 molar, this will react, and this will form 0.01 of this one. And this CH3CO minus, what will do, this is strong electrolyte, so this dissociate plus Na plus, and this is, let's say T equal to 0, this amount is there, and let's say I will let's say T equal to 0, this amount is there 0.0100, but T equal to T equilibrium, this will be complete dissociate. So this again make a problem of common ion effect. So one drops this H synthesis, whenever I add one drop of NaOH, what happens, this H fall, another case HCl plus NaOH become HCl plus water. So this is 1 molar, this is 1 molar, and this will become 1 molar. T equal to T equilibrium. So whenever I add 1 drops, then what it do, this will react with CH3COH, but this is very less concentration there, and whenever this react, this H form, and this form CH3COH, and this is completely dissociate, and this synthesize CH3COH, and this become a common ion effect. So it of this acid, common ion effect of this acid. So another drops whenever adding, this will not dissociate, dissociation will decreases, that we already discussed, right? Because this CH3COH, this is like that. So one drop whenever add, this synthesize this 0.01 molar, and this is complete dissociate, again this give this. And then another times whenever we are adding 1 drop of CH3COH, on that times what happened, that in the solutions already this is there, so it will do the common ion effect through this. So this NaOH will not react with this, but very less amount, due to common ion effect this is decreases. So but here for HCl, whenever you add 1 NaOH, that will completely dissociate into HCl, 1 molar synthesizing, and whenever we add another drop of NaOH, again this will react. So this HCl is, there is no common ion effect for HCl, because this is strong electrolyte, this common ion effect will not applicable. So this will, why common ion effect not applicable, because common ion effect, that is the principle of Lee-Chartres principle, and Lee-Chartres principle is applicable to weak acid and weak base. So Lee-Chartres principle is not applicable for strong acid and strong base. So here there is no effect of that strong common ion effect. So whenever you are adding NaOH, more amount of this is react with HCl only. Okay, so whenever HCl is present and we are adding drop by drop NaOH, this react only with HCl, not with CH3COH, because whenever it react with, at first it will react with CH3COH, but whenever it react with CH3COH, CH3COH and salt is prepared, and this salt give the common ion effect with acid, and due to this common ion effect, this reacting of this dissociation of acid decreases. So if we add NaOH also, this CH3COH will not react due to common ion effect. But this 1 drop of NaOH, if we are adding drop by drop NaOH, that can easily react with HCl. So it will more and more react with HCl only, not CH3COH. Okay. So graph will look like this. So here the kappa, here the volume of NaOH. So in the solutions, HCl is also there, CH3CO minus is also there. So it will be high because HCl is there, right? HCl means H plus is also there in a huge amount. So this is here, and you are adding that NaOH continuously. So due to NaOH, that H plus concentration decreases. So this will comes like this, because we already discussed na, strong acid, strong base, what will happen. So it will decrease like amount. Now here here the HCl and NaOH is reacting, but now after some time when HCl is over, here HCl is finished. HCl is finished. Then if we are adding more and more NaOH, then CH3CO minus is there. In this, after HCl is finished, what is there? Let's say when HCl is finished, what is there in the solutions? In solution, what are there? NaCl is there and CH3, COH there and CH3, CONA is there and water is there, and you are adding drop by drop again NaOH. Then this is base, this is salt, this is salt. So this base obviously react with acid, although this is weak acid, but it will react acid. So these reactions will happen. So we know that weak acid and strong base, what is the graph we will discuss. So first it will decreases due to common ion effect. After that it will increases due to salt formation. Okay, it increases. After that here CH3COH also over. Here that we will already discuss. Here CH3 COH is also finished. Then again we are adding more and more NaOH, then it will increases to like that. Okay, but this graph says this graph will comes from here. Why? Because HCl here the H plus concentration, here we do OH minus concentration, and we know that ionic mobility of H plus is more than OH and more than Na. So this is HCl due to, so this is the ionic mobility. Then conductance also, this main of H plus Na plus. So this is for H due to H, and this is H is over, this is H is over here, and this is due to common ion effects that CH3COH concentration decreases. After that Na is increasing, this is due to Na, this is due to Na plus, and this is due to OH minus. Okay, so this we already discussed. So let me draw in a clear picture. So how this graph look like. So this is kappa, volume of NaOH. So this is, let's say, acids. So this is acid, and this is HCl plus NaOH, and HCl is decreasing, synthesizing of NaCl. And after that here HCl is over, HCl finish. Then here due to common ion, now CH3COH is happening, so due to common ion, this is plus NaOH common ion effect, and after that here and this common ion effect, and then it will increase a little bit. This is due to increase in concentration of CH3 CONA. Okay, after that here here what is say that CH3COH also over, is finished. Then only OH minus will come, then only this. Okay, not this amount, this amount. This is due to OH minus adding of NaOH. Okay, and this is highest, then this is come to be this, and this is due to OH minus, this is due to H plus, and this due to Na plus. Okay, and this is the, let's say, volume 1, this is, let's say, that volume 2, and this is, this B1 is volume of here the HCl is not this one, this one. This is volume of its neutralization. This is the neutralization of HCl. So this is the where HCl, or you can say the volume of HCl is there. This is volume of NaOH required to neutralize HCl, and this B2 is volume of NaOH required to neutralize both CH3COH and NaCl and HCl. So this amount of volume of NaOH is required to neutralize HCl, because HCl is above, so this amount of NaOH required to neutralize HCl. Adding this amount of NaOH, HCl is neutralized, so this amount of volume required to neutralize HCl. And after that, this is due to common ion effects, and this is the increase of CO2 CH3CONA. This here the CH3COH is neutralized. This is finished. So this is here both HCl and CH3COH is finished. So this amount of volume NaOH required to neutralize both HCl and CH3COH. Okay. After that, here only for NaOH, no acid is there. So now the question is, what amount of volume of NaOH required to neutralize only weak acid? How much? So questions will be, so this is for neutralization of HCl. This is neutralization for both acids and bases, so both weak acid and strong acid, both CH3COH and HCl. So we know that HCl, to neutralize HCl, how much volume is required, and we know that how much volume required to neutralize both CH3COH and HCl. So now the question is, how much volume of NaOH required to neutralize CH3COH. So what will say? This is total. So this minus this, then the neutralization of CH3COH. So volume of NaOH required to neutralize only CH3COH is how much? This is total minus B1. So if this minus this one, if I neutralize this amount upon this amount, if I subtract, then this I will get. So this amount of volume, that is B2 minus B1, is required to neutralize weak acid CH3COH. That is, volume required to neutralize CH3COH. Okay, so these are whole about of the conductometric titrations or the applications of conductance. So today up to this, thank you.